Technologies actually do. Windows Technologies established in 1993. Okay, we are into modeling simulation software and hardware solution expert. Okay, we are having expertise in setting up the expert labs, which is a combination of software and the hardware. We are having world standard engineering simulation software for education. Like for your electrical engineering department, we are having NIPLAN, CASPOC. Okay, and what exactly this NIPLAN do is NIPLAN is the electrical power system simulation and analysis software. Okay, for your transmission and distribution. Then we're having CASPOC software, which do all your power electronics, electrical machines and drives. Okay, these two software are used in electrical engineering department. And now for mechanical engineering, we are having automation studio software. Okay, with single integrated multidisciplinary software for your hydraulics, pneumatic, and their proportional PLC, mechatronics, and electrical. Okay, then for we are having CNC simulator, which is 100% replica of your CNC machine. Okay, which has the control panels like Siemens, Haas, Heidenreich. Okay, then for your process and factory modeling simulation and optimization, we're having witness simulation software. Most of the colleges are do their only theory of the operational research, production planning and control, but for the practical we are having this witness simulation software. Okay, now for the thermal domain, thermodynamics, heat transfer, refrigeration, air conditioning, fluid mechanics, turbo machinery, we are having Flownex software for cycle simulation. Okay, and today we are going to see the Polysun software, which is a complete renewable solar thermal solar PV PVT hybrid simulation software. Okay, as I already told you, we are having expert lab. Okay, we provide the expert lab like industrial fluid power lab, mechatronics automation robotics lab, electrical power system and analysis lab, and renewable energy lab. Okay, these are some of our presence in the government institute. We are present in MSME Tool Room, DT Maharashtra, DVT Maharashtra. Okay, we are also present in TechCube. Some of the orders I have listed here. Okay, we are present in IIT, NIT. Okay, mostly IIT, NIT uses our software and hardware solutions. We are also present in FCRI. Okay, these are some of our presence in the institutes. Now, why Polysun? Why do you really need to go for this Polysun software? Because we all know that present world trend is on renewable energy. You know the costing of the petrol and diesel are running so high, so fast, and we have to shift on renewable energies. Okay, in our education, means Indian Educational Institute, we are only focusing on the hardware. Okay, we don't give student the design point of view. Okay, now but using this Polyson software, your student can actually design. Okay, design and research, do the research in the renewable energy, mainly especially on solar energy. Okay, and why Polyson? Because Polysun has the largest database of Indian equipment manufacturer like Vikram Solar, Excel Energy, Moser Beer, Adani Solar. Okay, and Polysun has a 150,000 system component from exhaustive manufacturers catalog like collectors, photovoltaic, batteries, heat pump, inverter. Okay, so we have to shift our main concentration on Polysun software as a design point of view. And for as I know, the hardware, hardware touch is necessary. After design hardware touch is necessary. For that we are having a solar energy trainer system. Okay, we have divided the solar energy trainer system in two parts. One is a solar cell study. For the solar cell study, we are having solar cell experimental setup with a spectral response. Okay, and what we actually solar cell experiment setup do is listed. I have listed some of the experiment like study of IV characteristics of solar cell. Okay, study of series combination of solar cell and the parallel combination. study of solar cell we can do with the help of this panel. Okay, then we are having a spectral response carrier lifetime experimental panel. From that you can measure the lifetime of a solar cell. Okay, all these equipment are Surya Mitra compliant. That is the best part of these trainers. Then we are having this solar photovoltaic stand, and we are providing two solar photovoltaic stand to do the parallel and series combination, okay, to demonstrate IV and PV characteristics. I have listed some of the experiment what exactly these stands do. You can just briefly go through this experiment, okay, so that you will get idea what exactly this solar photovoltaic stand do. Okay, so this is the combination of our Polysun software and Surya Mitra compliant trainer that we are providing in Renewable Lab. Okay, for next 1 hour, I'm going to give this to Andreas sir. Okay, he will show you the actual working copy of Polyson software. Okay, after 1 hour we will have a one question answer session. Okay, in that you will have to just click on that raise the hand button. Okay, by clicking that raise hand we will take your name and you can ask the question. Okay, at the end of the session you can ask your question. Andreas sir will give you the answer on that and moving forward to that. I am requesting Andrea sir, please present your screen. Okay, I'm going to stop sharing and you please present the screen and please show the Polysun software. Thank you so much.
Thank you very much, Megasane, and thank you very much, of course, all of you from IndiaSoft for this invitation. I hope you can see my screen now. Please confirm briefly if this is the case.
Yeah, it's visible.
Okay.
Yes, sir, it's visible.
Okay, thank you very much. Thank you very much. So my name is Andreas Wolf. I'm from Switzerland. Our company is called Vela Solaris. It is based in Winterthur, which is close to Zurich. And our company is actually originally a spin-off company of the Institute SPF, for Institute for Solar Technology, which is part of the University of Rapperswil, also in Switzerland. And SPF is also a testing institute for solar thermal collectors, which tests the solar thermal collectors to assign the solar key mark, the official European quality mark. So originally the software has been designed by SPF, and for the first time in 1992 already, but it was a totally different software to what we can see today. Up to about 2004, the software was only for solar thermal, and then a totally new software was designed, only the name was kept, Polysun, with a modular structure where you can add other technologies too. And that is indeed what then Vela Solaris has done. Vela Solaris was established as a spin-off company in the end of 2006. And we have then extended the software. Now it's not just for solar thermal, it's also for photovoltaics, it's for PVT, it's for heat pumps, it's for geothermal, for cogeneration, and other building integrated renewable energy systems. So today I want to show you briefly how the software works. Anyway, this is just an introduction, just to give you an idea. Of course, we are also offering training courses where we can go deeper into this. But now, today, I would just want to give you an idea. Usually, when you start working with the software, you would start with the wizard. Now here you can see the graphical user interface. We will get back to this graphical user interface in a moment. I will show to you how this exactly works. But usually the first step, and so I want to proceed in the way how you would see Polysun if you are a new user for Polysun, you would start with the wizard. When you install Polysun, the wizard usually pops up automatically, so you don't have to start it manually. But anyway, you can also start it from the button up here. And first of all, of course, you have to select a location. And this could be, for example, from the database. We have, you see here, the different continents, here the different countries. And this is a software which is being used worldwide. So we have weather data also from all over the world. And you can see here the cities of India, which are inside the software. But of course, you can also choose the location from a map. So you open the map, and then you can, for example, write the name of the city here. And then click on it, and then you see the cursor goes directly to this city. Now, Mumbai, of course, everybody knows Mumbai. And you can also zoom into it. You see, you can practically select the street, and it can be very, very detailed. You see, you can even zoom in further. So it's similar to Google Maps, but it's OpenStreetMap. But you can also select smaller places. And I want to show you an example from the mountains, because for the mountains, it's particularly interesting to select a location from the map. You will see immediately why. So I'm going to the northern province of Ladakh. And you see here, just to show where we are in northern India. And right in the mountains, you see also here the altitude, 2,700 meters. And now, when you confirm this location with OK, then you will see automatically here the natural horizon. And this is the natural horizon of the location which you have chosen. So you can see here the mountains, which you can see from this position. And if you change your position, also the horizon will change. And of course, this natural shading can be important if you simulate a location in the mountains.
Mr. Wall, sorry for disturbing you.
Yes.
Could you search a Gwalior location in that?
Sorry?
Could you search a Gwalior location in that? From database, can you search the city of Gwalior in that?
I'm sorry,
Andreas sir, the person is asking to search the city name Gwalior in Madhya Pradesh.
I'm sorry. Okay. So, okay, I will go back to this, but now we will try out. So, but you have to tell me how it is written, how it is spelled.
GWA
GWA
LIOR
LIOR. This is correct?
Yes.
So this would be the place.
Yes.
Okay. So yes, you can find it. And also don't forget, at any time, you can also use your geographical knowledge. So you can obviously zoom in, and then, of course, if you have a very small location, which you might not find in the list, you can also click on it manually, okay? But anyway, what I wanted to show to you here with the horizon, which is interesting, is so if you choose a location which is not in the mountains, you might as well choose it also from the list, especially if it is a large city, I mean, from the database, okay? It's not necessary to select it on the map. But if you have a location which is in the mountains, you get automatically this horizon, and then this can be important because you might have the situation that in the morning or in the afternoon you have no sun because of the natural shading. And then, of course, this will have an influence on the results. So for that reason, it can be important. So this is just an example, but we have seen this with the question which you have asked. You can choose any location. So once you have chosen the location, then you proceed and you can then choose a template, a system template. Now, I have explained to you, we have lots of different technologies. So we have an important filter here. And so you can, according to this filter, then see different systems. So for example, if you want to see photovoltaic systems with only photovoltaics, for example, then you can do your settings accordingly here. And then when you move the mouse here over the systems, you will see you have only PV systems. And we have heaps of them. I can't show them all to you right now. Then, for example, if you want to have a system with heat pump, then, for example, you can do again your settings here, and then you will have, for example, you will see here systems with heat pump, for example. So then you can choose the system which is most suitable for your simulation. And as Mega has already pointed out before, this is a software especially made for system simulation. So because of course it's not sufficient just to look at the single component, it's important to understand the system as a whole and how the components work with each other. Of course, we have also hybrid systems, combined systems. So for example, if you say solar thermal yes and heat pump too, then you see you will have, for example, here combined systems. All of these systems have solar thermal and heat pump, and you can see this, okay? Or if you say even photovoltaics, then you see here, for example, we have, for example, PVT, but we can also have, for example, here, photovoltaics, heat pumps, heat pump and solar thermal together. So you have many combination possibilities here. All over, you have about, in the complete designer version, you have about 1,000 systems. Now I want to start with an easy system to get quickly back to the graphic user interface where I want to show you other things of the software. So we choose just a solar thermal system for domestic hot water. You can do some basic settings here, but again, this will be shown more in detail on the graphic user interface. And then you can choose from the database a solar thermal collector. This is, we have databases for all components in Polysun, and there are real products inside. There are some anonymous because we don't want to make publicity for anybody. So we have some, as default values, we have anonymous products, but then you can, of course, find, you can choose from many manufacturers, as you can see this here. And of course, you can also write here in the filter the name of the manufacturer, and then only those will appear. Moreover, very important to other things, you see here data source. These are all official test results. So these products are not in there because the manufacturer wanted to have these results, but these are official test results. So you see from the data source, and then of course when you move further to the right, you see all the technical characteristics, like the different areas, the eta zero, the heat loss coefficients, and so on and so on. And also what is very important and what is valid for all the databases, for all the catalogs in Polysun, you can always add your own ones. All the catalogs are also editable, so you can add your own products. You just have to select a line, you copy, and then you change the marked line, and you can add your own products. So you choose a collector, then you set orientation and tilt angle according to the roof which you have. These are not suggestions. This, of course, depends upon the roof. So if you have, for example, here south, then this is 0 for the orientation. Okay, you can see this from the graph. If you have a positive value, it's towards east. Plus 90 is exactly east, and minus 90 is exactly west. And then you have the tilt angle. 0 would be a flat roof, 90 would be a facade. Then Polysun will suggest you a certain number of collectors. Well, this is a very small and simple system, so they just recommend one. And they recommend also a tank volume. I can override this value. For example, I can say I want to have 2. And then you see also the recommended tank volume changes. Now we have here already a 300-liter tank, so that's fine. But again, here you could go into the database of the tanks. You could click here on volume, for example, and then choose, so I'm sorry, then choose from another, also another tank with another size. Okay, so you have many sizes here. I'm sorry, that's my mouse. So, okay, so anyway, you are very free to choose here, and then also for the heat generator. And once you have finished all this, you click on accept, then automatically a simulation is done. You see this here on the right bottom. You see the green bar, which is running. And then automatically the first results are shown to you. Okay. Now, before I go further into the results, because we have a long results menu here with very different result types, which I want to show to you. I want to explain to you briefly how the graphical user interface works, because that is really what Polysun is about. That is where you work with. The wizard is just to start. So first of all, here to the left top, you have got information about your project. You can, for example, load a photo here. Here you have again the page of the location of the system. You can also change the location here. So if you don't want to use the wizard, you can change the location here. You see here the natural horizon, the mountains, as I have mentioned, because we have chosen a location in the mountains. So just that you see how this works. Of course, often you don't have the mountains, and then you will have a flat curve. And then you can also click here on edit. You see, for example, here the solar path, which changes from location to location. So that is the solar path which is valid for Northern Ladakh. And of course, if you have a different location, the solar path will change. So this is always automatically set for each location which you have. And you can also then add artificial shading, like by buildings and so on, and then you can enter them here. And then you have got a list of system diagrams here. So the different systems which you want to analyze, you can easily, for example, do settings also directly here by clicking on directly on the system. So if you double click here, you open the dialog window and then you get into the catalog again, you can change. And this is valid for all the components. So for example, here you want to change the boiler, you get into the catalog and so on. The tank, whatever, you can click on everything. It's always interactive. Everything what you see here to the right is never just a picture, but it's interactive. Even the single pipes, you know, you can change insulation and pipe dimension and so on. So this is very, very detailed and very flexible. And you can also copy the system. So you can then, of course, rename it. Now I just write 2. And then you can, for example, change values. So you could, for example, say, now I have here 2 collectors. Now I want to see how it is with 1. So let me do it here, because otherwise it will be a little confusing. So I write here 1. And so I try here 1 collector. And then I copy again. And I try with 3. Just a very simple example, but just to do something quick to show you how this works. And then you could, for example, compare the results quickly. Of course, you can then look at the detailed results, which we will do anyway very soon. I told you after I have finished to present to you the graphic user interface. But you could say, for example, system comparison. Then you can choose the systems which you want to compare with each other. So these 3. So then again, the simulation is running for all 3 systems, because of course we have changed the value. So we have to wait for a moment that we can see the results. So now the 3rd system is being simulated, as you can see from the green bar. And now you see the results. Now you can see, for example, here the solar fraction, and just, of course, the most important results, because this is a results overview. And here you see, for example, the solar thermal energy, which is generated in this case. And you can see, for example, here the single steps from 1 to 2 to 3 collectors. And you can very clearly see that here between 1 and 2 collectors, there is an enormous advantage, an enormous difference. So it's absolutely worth it to install 2 instead of 1. But the 3rd one, which is the black bar, is not really necessary, because you see, then the system gets to its limits. We have just a small system, just a consumption of 200 liters per day. And you see here, the difference is very, very little. And it's only in winter, it's a little higher, but for the rest of the year, it's really not worth it. And so we don't need really another collector. So this you understand here immediately. And this without going into details. But of course, we will go into details, you will see it. But just to show to you how quickly you can compare. And then you have got here the list of templates. Now, you saw already in the wizard, when I showed to you the filter, that you can choose your system from the list, but you can also, if you don't want to use the wizard, you can also choose your system directly from here, okay? So you can, for example, say, okay, I want to simulate this system, so I say here, do you want to add this system to the project? I say yes. And then the system is up here, and now you can simulate it. Okay, so you can simulate all the systems which are up here. These are only templates, but you have here an enormous list of templates. So you have here, of course, also you have sorted them in folders according to the applications, but you have, of course, also different technologies. You see, you have here, for example, traditional systems, which are also inside Polysun and necessary because you want to compare. Maybe you want to explain to your client or to anyway to somebody why one system is better than the other. So you have to show also the worst system. And so you have many different technologies here. And well, I mean, I can't present them all to you because there are so many. You see here also geothermal energy, so many. And then after all these systems here, you have also company systems. And these templates have been designed for companies. So the difference is that they don't have anonymous products as default values, but they have directly the company products. And you can see also how these companies work. So you have here an enormous array of systems. You see some also with different graphical representation. So this would be the template list. Now let's go back to the graphical user interface. I have already shown to you that you can click here on everything. And you can do your settings. You see also here on the graphical user interface these boxes. And these boxes are the controllers. So these are the controllers of the system. You see they are responsible for different parts of the system, different components. Now the time, of course, is not enough to explain to you the controllers, but I just want to tell you that you have these controllers in Polysun and that you can also compare two systems with each other, changing the way how the components work through the controllers. So not only change components as we have done it here or add new collectors, but also control the same components in a different way. And so I just open one as an example. You can decide where you set your temperature sensors. You can decide which components are controlled, at which temperatures they should switch on and switch off. So this is also important to know that you have this. Of course, don't worry. I mean, all the systems here, the 1000, are all already preset with certain values. So it's not, you never have the situation that you have to set the controllers by yourself if you don't want to, but you can change them. You can edit them, and you can simulate the system in the way you like it. And then you have also here in the center, you have also the toolbar, as we call it. You see all these symbols for the single components. Now you might recognize a few, like you have here the PV module, you have the electric vehicle, you have the solar thermal collector, you have many more. And you might wonder now, why do you have this? Now, this is necessary if you want to add new components to a system. Because what you can even do, I mean, I have told you we have already 1000 systems, so it should be enough, you would think. But unfortunately, it's not, because you have always some special system, some special hydraulics, which you want to design in a special way and then you don't find maybe your system as you like it, and then you can create it. So you can, for example, now I just show you an easy example just to give you an idea. So you have, for example, this system here, and then you say, now I want to add the PV system to this, okay? So you click here on PV, then you place it here. You need electric consumers because, of course, you have also consumption, electricity consumption in the house, and you might need the grid, okay? So you place the components here. Then, of course, you can click on them. You can do all your settings. You can go back to the wizard, even if you want to, and do your settings and then simulate it. So you see, you can edit these templates too, and you can edit them also hydraulically. So you could, for example, say, I don't want this relay valve here, so I delete it. So of course, then I don't need the controller either. I don't need this pipe anymore, and this T I don't need. And then I reconnect the tubes with each other, the pipes with each other, and then I can simulate it again now without the three-way valve, for example. So this is just a very easy example. Of course, you can do much more complicated things. You could even, if you want to start from scratch, but of course I don't suggest you to do this in the beginning. Start with one of the systems which you have already, because otherwise you will have too much work, and maybe do just the changes which you need to do, okay? So, but anyway, this you can do. You can also place new tanks. You can do anything. Okay, so this is very important about Polysun. This is an important characteristic. So this is the graphical user interface, okay? And then you have got here the menus. You have 6 menus in Polysun. One is about the project. There is not much to say about that. I think that's very clear what safe project and open project and closed project means. Then you have here the system diagram menu, which is also not so important because usually you work with the system diagrams directly here. But then you have a very important menu, and these are the results, which I have promised to you already twice to show it to you, and I will. But now I will finish for a moment all the menus, and then we will have a look at the results. And then you have got the catalogs. So, which means the databases. So you have got in Polysun databases for all components. I already told you this, and they are also really vast, and you can also add your own components. And then you have options. So here you have, for example, settings where you can change the currency, which of course is necessary for the economic viability analysis. You can change units, you can change the language, so you have many different possibilities here. And you have got a user manual. The user manual in Polysun, you see it's almost 300 pages. You have lots of information here which you can study when you have time. So for example, here you have the introduction, you have about PV, solar thermal, heat pumps, controllers, which I have already mentioned, simulation results, and profitability calculation. And you have also videos. So you can click here directly on the videos, directly on the links. You see they are linked directly to YouTube. So you don't even have to look for them. So also these can be very useful. And so now this is just to give you an idea about all this, that you have an overview how you can work with Polysun. And now let's have a look at the results. So for example, we have simulated this system here, and we go here when we simulated it first, we saw the results overview, okay? But of course, the results overview is very rough. This is mainly to give you a basic idea of the system, if more or less the results are the ones which you desire. So if you want to go further in detail, you can open system results. And the system results, you see, are already much more detailed. They show you the most important values month by month as a table and as a graph too. You see, every time I change the line, the graph changes too, because it's according to what you can see here in the table. And here, of course, you have essential values, for example, here for a domestic hot water system with solar thermal. The total energy demand, so that would be the theoretical demand. Then you have the total energy consumption. You have got, for example, the solar radiation onto the collector area. You have got the solar yield of the system. So how much solar energy goes into the tank. You have then the same values for the auxiliary energy, so the additional energy, which is in this case a gas boiler, but of course you can put anything else. You can put a heat pump, you can put oil boiler, whatever you need. And then, of course, you see the energy from the heat generator to the system. And then, of course, in combination with the solar, you can calculate the solar fraction. So you see how much of the energy in the system is solar. Now, this is the overview of the system, but then you might want to know more, and you can go into component results. So you can go here, as the name says, this will show you the single results of the single components. So here you don't have just an overview of the whole system, but you can check component for component. So for example, here, if we look at the collector, collector means here collector field, then you can see, for example, here also the temperatures at which the system is working. So for example, here, this is the temperature of which is measured for 24 hours. So all the time, so even if the solar pump is not running, but for example, temperature during operation, here we have the temperature when the average temperature when the pump is running. So you see more or less the temperature level. You see also here the maximum temperatures. And so you get a good idea here of more details. And if you have stagnation in the system, you would see also an additional line. We even have, yeah, that's quite good. So you see here you have 5 days of stagnation. And so you can check these values also here. Then you have, for each single component, you have further information here about the hot water demand. You see here, for example, for the weather data, so you can see exactly the values. You have got here then also information, for example, for the storage tank. And talking about the storage tank, you see you have got here 12 layers. So this is also important to understand. Polysun is simulating the system, the storage tank in 12 layers, because of course you have to simulate also the stratification of the tank, because the tank is not just one component, it's actually already a system by itself, because you obviously the warmer water is lighter, so it will go up. And that, of course, is something very important which must be considered. Now you see here the average values for each month. And this, of course, you might say is not so interesting, because we are talking here about temperatures. I don't want to see average temperatures. I want to see temperatures of the moment. And then you can go deeper into it, and you can go, for example, into graphical evaluation. You can choose here a week or a month. So, for example, we can choose a week here. Then you can add a curve. So, for example, here collector. Now we are interested to see the collector field yield. Then you see the collector field yield appears here already. Now let me look for another week, which might be more interesting. This is more interesting because here we have a good day and a bad day. So, and then you can, for example, then add here the storage tank. You see that you are choosing, you are, as a user, you are selecting the values in which you are interested. So let's choose at the top layer and layer 4. You know, you see here we have lower and the top layer. But now, of course, we have 2 units. So we have to work with 2 axes, otherwise we can't understand anything. Then we can change also the color here, that it is clearer, and now you can see the curve properly, okay? And this is just an example, because you see it's the user who decides what he wants to see. And but here you see, for example, how the system behaves exactly. You see here, and that's the reason why I wanted to choose a week with good and bad days. Here you see when we have this bad day, how the temperature in the lower layer of the tank drops. But in the upper layer, it is kept high. Of course, we have the boiler here, which is heating the upper layer, so or the upper layers. So we see that exactly here with the curves how the system is behaving. So this is really very interesting and detailed. And if you want to know even more, you can go into the simulation analysis, and in the simulation analysis, we will see even the single time steps. So you see here, for example, exactly what is happening in the system. You see here, for example, we are on the 6th of January at 11:40 and 56 seconds. And we see which simulation time step we have. It's simulation time step 2623. So you see also clearly here, we are not talking about an hourly simulation. It's a dynamic simulation with variable time steps, which can be shorter or longer. And here you can see, for example, or after only 6 days, we are already more than 2,000 time steps. And you know, 1 year has 8,760 hours. So here we are clearly not talking about an hourly simulation. It's much more detailed. And you see exactly what is happening in the system. So it's very transparent. And you see also here in the tank the exact values in the single layers. And if you click here on plus, oh, sorry, I clicked too quickly. No. Yeah. Now, then you see exactly also the time which passes from one time step to the next. Okay. Here, for example, it's 4 minutes. But here, for example, you see it's only 10 seconds. So it depends, of course, what is happening in the system. Then Polysun simulates the length of the time step. So these are, you see, this is a little overview of the results from very rough to very detailed. You see, we have the whole array, and it's actually you as a user who must decide what level of detail you want to see in which moment, because you need everything. Sometimes you need an overview and you get it. Sometimes you need details and you get it. So it's really depends upon you. Then we have additionally also reports. Now, the report is not really made so much for you as a user because you have so many possibilities to check the results. The report is really made more for the client. So if you want to present your results, you can generate a report. But the report, I will now generate one just that you see how it looks like. But you see the report is really made to present results. It's because the report is summarizing results. So you see here, you get, for example, an overview of how the system looks like. You see the location again, the photograph of the house. Then overview of the most important results only, most important components only, and you see just a few graphs, just the most important graphs, not more, because we don't need here all the details. Okay, so this is really just to present to your client the results. I'm sorry, I forgot to mention here in the top corner, you can also load your logo if you want to. Okay, and moreover, we have also a profitability calculation. Now, the profitability calculation works in that way that you can compare systems with each other. And actually, it's important to compare. It's necessary to compare because you must show how one system is better than the other. So what you should first do is you should define your system. You should, so I open this briefly that you get an idea also here. So you should first define a few systems which you want to compare with each other. Okay, that's the first thing. You must make up your mind in this regard. Then, of course, you must get information about the costs, because Polysun obviously knows all the technical data. That's clear in the databases. Of course, Polysun does all the calculation, but Polysun doesn't know the costs. So this you must feed in, like here, for example, for the conditions, the electricity prices, for example. Of course, you can change the currency. I have shown this to you briefly in the settings. So, of course, you can select Indian rupee. And then after you have done all that, you define also the system costs, if you have operation and maintenance costs, even if you maybe need a loan to finance the system and you need then to pay interest on your debt. So this you can all set here. And once you have done that for all systems, then you can go on to profitability system comparison here. And then I have prepared something. You will see something like that. Okay, I hope you can see it. So this is now a comparison of 4 systems, just as an example. And then you will see here these curves. And then you can, for example, understand which one is more convenient than the other. So here we have, for example, one reference system, which is the black curve. And we have these other systems which are better than this system, because you save money over the time and you see how the curves go up. Of course, we must not forget, in the beginning, they cost more money. You see, that's the reason why they start here in the negative area. But then, of course, thanks to the savings, you get a sort of payback, and the systems get more convenient. And the interesting thing here is also, you see how this yellow system is the most expensive one, but in the long run, it's the most convenient one. So you see, it's not just a question of if a system is more convenient than another one. It's also a question, how much time or how much patience do you have? If you cut after 10 years, let's say, then of course the yellow would not be the most convenient, would be the red one. But if you cut after 20 years, it's the yellow one. So it's always a point of view. And that's, of course, also important to convince your clients, because some have the horizon which finishes after 2 years. And that's, of course, then the reason why they never invest, because they see only the initial investment, but they don't look ahead. And that's really important that they look ahead. And that, of course, you can show them here on black, in black on white, that it is convenient to look ahead, to look into the future. So this is now an overview of how you can use a Polysun. I have shown you the most important issues. And to finish, I want, before you can answer, before you can ask some questions, I want to show you a few examples which I have prepared here. For example, here we have a hot water system with heat pump. Now maybe we can even change the location of the system again, because now these have been defined actually for Pune. So we change the location also here. And then you see you have here, so a hot water system with heat pump, and you see here the electricity of the the household. You can click here on the icon, and you see here we have different consumption profiles where you can choose from. And then you have got here also, of course, you have to set the annual consumption. And so this you can set here. Then you can, for example, compare this system, which has only heat pump, with a system which has got also PV. Okay. And then you have here a system with PV and battery. Okay. And this is a small battery. Then, of course, what means small? I mean, you have, of course, also here a catalog where this is all precisely defined. So you have here different battery technologies. So this is just now a small battery, we call it this way. And here you have a system with a large battery. Okay. And then you can now say, okay, I want to compare these systems with each other and see what happens. And so you can select what you want to compare, as we have done it already before. Now, again, Polysun, the Polysun simulations are running. You can see this also from the green bar and the green arrow here. And in a moment, we will see the results. So just wait a second. And now we can see, for example, here, important results. So one important result, for example, is the energy which we need from the grid. And we can see clearly here that if we have only the heat pump, no PV system, how much energy we need from the grid. You see the green bar here, the first. Then we see, for example, the system with PV. You see how it's drastically cut. You see it's roughly half now only. But then we even add a battery and we compare with the small and the large battery. And you see now with the large battery, it's the blue bar. And you see, if you now compare this with the initial configuration, how much less energy you need from the grid. You know, the differences, of course, are enormous. And that's just an example. You see, you can, of course, compare many other values too. Yeah, I think because it's already 11 for me, you can see the time here. And of course, for you, it's 4 o'clock. so I think this should be okay for the moment. And or maybe I show you quickly this also. We have also here also systems where you have, for example, you can simulate also heating and cooling for the building. And then you can, for example, simulate it. Maybe I show you this quickly, because then you can go into the analysis of this system and see, for example, also for the building, how much heating energy you need, and how much cooling energy you need. So, for example, here you see thermal and electrical results, because we have both of them here. So then you can go, for example, here, you see you have the system for heating. You see the energy which you need here for heating. And here, sorry, here you need what you need for cooling, okay? This is negative here because it's cooling, it's not heating. So otherwise it would work mathematically, but you see this clearly here. So you can analyze these two. And then, for example, we have also process heat. So if you have, for example, an industry, and you can also simulate these types of systems. Yes. So yes, but now I don't want to make it too long for you, because I'm sure you will have some questions too. And so I want to give you a chance now to ask them.
Thank you, Andreas, sir. It's
welcome.
a request to all participants. Please raise hand before you ask a question. We will take a one-by-one question and answer. Okay, so it's a request. Please raise hand before asking the question. Any questions from participant side?
Yes, can I ask?
Yes, sir.
Yes, I have
a question.
Let me quickly check here. So one question is, could we design a solar tree power generation system? I'm sorry, what do you mean exactly by solar tree?
Mr. Kiran, please elaborate your question.
Aslam.
Varun,
Solar tree consists of solar panels arranged in a tree form. Yes. Well, you can actually, as I have pointed out, you can design your system freely. Okay. So you can also, of course, have, for example, several.
Please mute yourself.
Yeah, you can, for example, also have several collector fields. I want to show you a quick example. Like here, for example, you see you have two, but you can have also 3 or 4, or how many you want. And so you can design your system freely. Yes, so this is possible. Okay. Are there any other questions?
Sir,
yeah, you're welcome. So for the
yes.
cost, I think it's good to contact IndiaSoft. and IndiaSoft will be happy to make an offer to you.
Deepak sir, you can ask the question now.
So in any case, we have different conditions for universities and companies. So yes, please contact IndiaSoft.
Varun sir, you go ahead with your question.
Yeah, so this is Varun here.
Yeah, my question is that. Yeah, Varun, you can ask, then I can ask after that.
Okay, fine. So, Mr. Andreas,
Yes.
so I have a doubt, like, can we simulate constant solar power based thermocline systems? One.
Yes.
Second one, the latest, that is beam down systems, beaming down of concentrated solar radiations.
Yes.
So is this too possible?
Yeah, so generally, when it comes to solar thermal, we have also concentrating collectors here inside the catalog, as you can see here, different types. So you could also define your concentrating collector here in this catalog with all the values, and then simulate it. So this is also possible. We have also some templates regarding that, but of course then you can also create your own templates.
Okay. Can the results be extracted in a Excel format?
Yes. When you have the results, now I show you a quick example. So there are two possibilities. One is that you export them directly here, or you copy them practically with Control C if you have Windows, or Command C if you have Mac, and then you copy them directly in your Excel. This is generally for all results, for all tables which you have in Polysun. Additionally, you have the tabular evaluation, which I didn't show to you because, I mean, there are so many things. I showed you the graphical evaluation because it's more interesting. But you have also the tabular evaluation, where you have, of course, this huge table with all the values here, for example, the hourly values, but you can have also the time step values. And then you can, for example, say what you are interested in. So, for example, here the electricity consumption of the heat pump. And then you see automatically this column is selected, and then you can also copy it into Excel.
Yeah, that solves my doubt. Thank you.
You're welcome.
Next.
Deepak sir?
Yeah, my question is that how can we use the Polysun software in the installed on-grid solar power plant?
Well, we have got, if you say on-grid, so I imagine you're talking about photovoltaics. So we have got here, all sorts of systems. And as you have seen already before, of course, we have the grid inside. I mean, I showed this to you also when I edited the system here. So, of course, we have the grid, and you can also define what type of grid you have. You can simulate, of course, on-grid systems. Yes. I have seen also here.
Can you explain with the same with any example?
Yes.
Can you explain with the help of any example?
So if you have, for example, the the grid system here, you mean?
Yeah, actually, there is a 100 kilowatt plant installed at our premises. Then how can we use the Polysun software in that installed plant?
How you can use Polysun in the already installed plant?
Correct.
Well, the software is actually a simulation software, a design software. So usually you use the software before you install the system to design your system. Of course, you could also check how your system is working. So, for example, if you have the system here, now I do something very quick, and then you do all your settings. After you have done all your settings for the grid, for the consumption, so you do here your consumption. You could see that you have many different profiles here. You can generate your own profiles. You define here your consumption. You define, of course, your PV system here in detail. You have a very large catalog for all PV modules. You can define your PV system also through the wizard. You can define the inverter. And then, of course, also you can define the grid. After you have done all these things, you simulate your system, and then, of course, you can check, for example, here, so the yield of the PV system. You can see your total electricity consumption. You can see how much you have self-consumption in your system. Then you can add maybe a battery and see how it changes. So yeah, you can do this. And of course, you could also define the system which you have already installed and compare. This you could also do.
So basically, I think he was the participant was asking a connectivity to the real hardware plant which is already installed. Basically, this is a predictive simulation software and design software. We are predicting before the actual implementation, or if we have done the implementation, then we can also replicate that here virtually. But it is not directly connected to any hardware.
Yes, that's correct.
Yes, that's the answer for you. Deepak sir, your question is done.
Yeah. Thank you.
Okay.
Next is
So there were a few questions
sir.
before, which I don't want to miss out on.
So anyway, wait, they are raising their hand, so they will ask that again. Don't worry.
Yes, but you see in the list here, there were a few questions which I didn't answer so far.
Yeah.
So regarding the weather data, for example, there's one question.
Yes.
So you can have both. For the weather data, you have it here on the location of the system page, and you can use the weather data which is already inside your software. Okay, because when you install it, you get the option to install it with or without weather data. And then you can also choose single continents, for example, so you can use that data. And that means you can work offline. Okay, so it's practically standalone. But you can also use the web service and download the weather data from the web. So both are possible. And you can even, if you have your own weather data and you want to use that, although it's not necessary because the weather data which are inside here are anyway coming from Indian meteorological stations, and then they are re-elaborated for the software to have an average year. But if you still want to do it, you can also create your own CSV files, and then you can also simulate your own weather data. So you have actually many possibilities regarding the weather data. So I hope that has answered your question.
And
Then-
so as far as the licensing policy for the academics, we have a bundle packages of 10, 20, 30 users. And for the commercial
Yes.
purpose, we can give the standalone licenses also.
Yes. Yes. Anyway,
Next-
for the licenses, I suggest you contact IndiaSoft, and then we discuss this individually. But in any case, yes, we have many possibilities, and which I'm sure we will find something which suits you.
Yeah, any license related or quote price related, please mention your query in the feedback form, which is the link is provided in the chat box. So, Dulichan sir, you can ask your question.
Yes, sir. Thank you, sir, for giving me this opportunity. Actually, my question is that is there any provision to provide a Matlab interface? Means we can dump the Matlab simulation, or can we simulate it with that Polysun simulation software, or it's a separate platform?
That's a good question, because there was I don't know if you are the same person, but there was also a question in the list.
Yeah, that was asked by me on this.
Good, because I just saw it and I thought, oh, I must not miss out on that question too. Yes, that is also possible. We have also an interface with Matlab, but it's another type of Polysun software. It's not the Polysun designer software, it's a Polysun premium software. And this is especially used for the controllers. So I can't show it right to you now here, because this is the designer version. But yeah, if you're interested in this, we can go deeper into this topic. But I have already explained that we have all these controllers here, okay?
Yes.
And regarding the controllers, I have opened one briefly before. We have also, let me quickly show to you. We have also the so-called programmable controller, where you have even more flexibility when you want to design your system. You can practically not only do your settings as we have seen it before, but you can define also your own logics, okay? And that programmable controller is inside the designer version, or also educational. So this is, you get this automatically. But additionally, we have also the plugin controller, and the plugin controller then requires another software, which can be Matlab, so that you practically control Polysun externally. But it's really a quite sophisticated application. It's when I'm thinking of all our users, it's a very small part who is using it. Anyway, yes, this is available.
Thank you, sir.
You're welcome.
Next question by Ankur Gupta ji. Hello, Ankur Gupta.
Sir, my question is that what is the reliability of this software? And
I'm sorry, could you repeat, please?
Reliability of this software.
And
reliability.
what is the percentage of these software results are obtained from this simulations?
Accuracy percentage.
How can we validate these results from the experimental results?
Yeah, well, the software has a long history, as I have explained to you before. It was first designed in 1992, and then the current version in 2006. Then, of course, it was developed further and so on. But all the components you see today and all the technologies you see today were all validated when they were entered. You know, it was never something was added without any validation. So, for example, as we have started with the solar thermal, This was the very first technology. As I have mentioned, the solar thermal is coming from the testing institute, SPF. So, of course, the validation was very easy to do because it was all in-house, you know, because you have the testing institute too. And now, of course, we have also results from other testing institutes, but they are, of course, all validated. Then for the other technologies, we have other partners, and but every time we add a new technology, this is validated.
Okay. And sir, how much percentage are accurate, these results?
Well, the accuracy depends mainly, the accuracy technically is very, very high. So, but what is the main question in the end when you do the simulation is how accurate are the settings? Okay, not the for the software, it's no problem because obviously we have all the technical standards inside. And the state of the art is well known. So, but then of course, it's important to do precise settings, and that is then really what influences the results.
Okay. And sir, can we compare these results from the experimental results?
I'm sorry?
Sir, can we compare these results from the experimental results?
Yeah, you could do that. Of course, you could do an experiment and then you could simulate it, or the other way around, of course. As also the other person has asked before, you know, if it's connected to a real system. Well, it's not connected, but of course you could simulate your real system. Of course, that's the idea. And mainly it's used for designing systems. So yes, of course you can do that. But what I also really suggest for university and schools is to use it for teaching, because for the students, when they start working for the first time in that field, or start studying in that field, for them it's very hard to imagine something, and the software helps them enormously that abstract situations become real, and they also see very easily and quickly how the single settings or the single components in a system can influence the results, and what are also the points where you can change the way a system works. And so for students, it's an enormous help. And also it's usually fun for them because they are active, you know, they don't just study, they are doing something, and it's really learning by doing. So I really suggest you to use it also for teaching. And we have also many universities around the world who are using it for teaching.
Okay, sir. One last question is, sir, are these results are acceptable for their publications?
I'm sorry, could you repeat
Yes,
please
it's
again?
totally acceptable for the publications paperwork.
For the publication?
Yes, sir. For research publications, these results are valid?
Yes, accepted. There are a huge number of
yes,
paper
it is
already.
used also at universities. Many scholars have also used it for different publications. Yes, of course, you may. Of course, you need a license, that's clear. But if you have a license, then of course you may use it, yes.
Okay, sir. And what is the
chat
price
box.
of license?
Prices, sir, the email ID has been provided in the chat box. You can inquire on that, or in the feedback form, you can feed the query related to prices.
Thank you, sir. Thank you, sir. Thank you.
Sir,
Thank you.
if you
Thank
see the
you.
chat box, and those participants who wants a question, raise your hand. So 2 questions in the chat box. One is your software can be used for monitoring existing system and can be detect fault in the system. So monitoring existing system and detecting fault in the existing system. Dr.
The monitoring. Yes. It's actually, we have had also cases where we had solar thermal systems. I'm recalling one case where we had a solar thermal system which did not work properly. And then there was an argument about the manufacturer and then the installer. And then, of course, you could simulate it with Polysun and analyze this way also the results. Yes, this is also possible. It helps you to
in the sense in a monitoring
system, and also it helps you if you have certain settings which maybe are wrong in the real system, and you simulate them, what will be the effect? So yes, as I said, really what is really important, it's also that you have all the different settings, you know, that it's not just component, and then it works ideally. No, it doesn't. You have the possibility to change this, and so you can influence the way how the system works. The controllers are really important because they are like the brain of the system.
One more question: can we use the software to design number of systems? From Chavan Poonam. Can we use software to design number of systems? Yes, that one, sir.
Yes, so as I have shown to you, you can also design your own systems. You know, do it all by yourself if you want to. So you can, for example, here define also the tank. You can design it here, for example. You can choose your components from here, like I have already shown to you with PV, for example, here collector. You can have here the pump, and then of course you can also here then connect the single components with each other. And then you can, of course, add your controller, and then you can set your controller, and so on and so on. Of course, we don't have the time now, but yes, you can design your system freely. You can. There's no limit in this. I mean, once you have a license, you can do with the software what you want, and you can edit, of course, systems as we have seen here. So you are, and then we have already 1,000 systems inside. I usually suggest start with the systems which you have, because then you get to know the software, you know how it works, and so on. And then you proceed step by step, but the flexibility is really high.
Okay, sir. Thank you very much. Next question, please. Any question? Or you can raise your hand. And you can also fill the feedback form. The feedback link is also provided in chat box. So certificate will be issued according to the feedback details or name and institute name provided by you. So any question? Any question? Then if nobody's having a question, then we'll end our session. So last chance to ask a question.
And in any case, I want to tell you all, I'm not out of the world even after we have finished this session, and certainly Indiasoft isn't. So if you have questions later on, if you, then something pops into your mind, just send us an email, just contact Indiasoft, which will also pass on your emails to me, and you can ask any questions at any time. Also, you can download a trial version from our website if you want to. It's free of charge, and our website is www.velasolaris.com. Anyway, Indiasoft will give you all the information, and so yeah, just be in touch, and thank you very much for your interest. Thank you very much for your numerous participation. It was really a pleasure to meet you this way, and I certainly hope one day we will meet personally. Thank you very much.
Thank you so much, Andreas, sir.
Yeah. And thank you very much again to all the staff of IndiaSoft. Really, really great. Thank you for your support.
Thank you so much, all the faculties. Okay, if you have any question, query, please mail us. Our mail IDs have put in the chat box.
And feedback link is also provided in chat box. Please fill feedbacks in 2 minutes.
Thank you, Andreas sir, for a wonderful session. Thank you.
You're welcome. Thank you. Bye-bye.
So we close the session. Thank you, everybody.
Nice
Thank you, everybody.
evening for you. Bye-bye. Thank you. Bye-bye.
Thank you.